Hi everyone, welcome back to Mindverse. Today, we are going to take a journey so far back in time that it almost feels impossible to imagine. We are traveling to the era when the first stars were born, when the first galaxies came into existence, and when the silent dark universe lit up for the very first time. The story of how stars and galaxies were born is not only about the distant cosmos, it is also our own story. Because without the first stars, without the galaxies that formed around them, we would not be here today. The atoms in our bodies, the air we breathe, and even the ground beneath our feet all trace back to those ancient cosmic events. So sit back, and let's travel to the very beginning of light, to the birth of stars and galaxies. After the Big Bang, the universe expanded with incredible speed. In the first few minutes, the basic elements were formed mostly hydrogen and helium, with just traces of lithium. At that time, the universe was unimaginably hot and dense, but as it expanded, it began to cool. Light existed, but it was trapped, bouncing around endlessly in the thick soup of particles. The universe was like a foggy room where light could not escape. It wasn't until about 380,000 years later that the fog lifted. At this point, atoms formed and photons could finally travel freely through space. The universe became transparent, but even then there were no stars, no galaxies, no planets, just endless darkness filled with invisible gas. This period of time is known as the Cosmic Dark Ages. If you were there, you would see nothing at all, only silence and emptiness. But deep within that emptiness, tiny seeds of structure were already forming. When the Big Bang occurred, matter was not perfectly spread out. There were small fluctuations, tiny differences in density that were only a fraction of a percent. These fluctuations were enough to give gravity something to work with. Gravity began pulling matter into slightly denser regions. Over millions of years, gas slowly started collecting in invisible halos of dark matter, which served as the hidden scaffolding of the universe. Without dark matter, the gas might never have gathered together to form stars and galaxies. But because of it, the universe was quietly preparing for something extraordinary. Imagine vast clouds of hydrogen gas, stretching light years across. At first, they were cold and quiet. But as gravity pulled them tighter, they began to heat up. Deep inside these clouds, knots of gas formed, becoming denser and denser until their cores grew so hot that nuclear reactions could begin. This was the birth of the very first protostars. Slowly, they gathered more material, pulling gas inward, growing bigger and hotter. And then, at last, fusion ignited. Hydrogen atoms fused into helium, releasing a burst of energy that pushed against gravity's pull. The first stars lit up, piercing through the darkness of the universe. For the first time in hundreds of millions of years, light filled the cosmos. These first-generation stars were not ordinary stars. They were giants hundreds of times more massive than our sun. Their brilliance was unimaginable. They shone millions of times brighter than the sun, flooding the universe with ultraviolet light. Their lifetimes, however, were short. Unlike smaller stars that can live for billions of years, these giants burned through their fuel in just a few million years. But in that short time, they changed the universe forever. They emitted radiation that began breaking apart the fog of hydrogen gas, slowly reionizing the universe and making it transparent again. This period is called the epoch of reionization, when the universe went from darkness to light, thanks to the first stars. But the most important thing these stars did was act as cosmic forges. Inside their blazing cores, they fused hydrogen into helium, then into heavier elements like carbon, oxygen, nitrogen, and eventually iron. When they ran out of fuel, they collapsed and exploded as supernova, scattering these elements into space. These explosions were unimaginably powerful, releasing more energy in a few seconds than the sun will produce in its entire lifetime. The shock waves tore through space, compressing nearby gas clouds and triggering the formation of new stars. The universe, which once had only hydrogen and helium, now had the building blocks of planets, oceans, and life. Some of the most massive stars ended even more dramatically. Instead of exploding, they collapsed into black holes. These early black holes may have grown rapidly, feeding on gas and merging with each other, eventually becoming the supermassive black holes we see today at the centers of galaxies. In this way, the first stars not only created light and elements, they also created the seeds of some of the most mysterious and powerful objects in the universe. As more stars were born and died, gravity continued to pull them together. Small groups of stars merged, forming larger and larger systems. These were the first galaxies. At first, they were small and irregular, clumps of stars surrounded by gas. But over time, they grew by merging with each other, forming the majestic spiral and elliptical galaxies we see today. The Milky Way, our home galaxy, was born from countless such mergers over billions of years. Each collision triggered bursts of star formation, lighting up the cosmos even more. Galaxies became the islands of light in the vast cosmic ocean, and they continue to be so today. The role of dark matter cannot be overstated. While stars and gas made up the visible part of galaxies, dark matter provided the invisible framework. Galaxies formed inside giant halos of dark matter, which held them together with their immense gravitational pull. Without dark matter, galaxies might have never formed. This hidden substance shaped the grand structure of the universe, arranging galaxies into clusters, filaments, and walls that span billions of light. Together, they form what we call the cosmic web, the largest structure in the universe. It looks like a vast network of glowing threads, with galaxies strung along them like pearls. And at the intersections of these threads, galaxy clusters formed, some containing thousands of galaxies bound together by gravity. Even today, when astronomers point telescopes like the James Webb Space Telescope into the deep universe, they see galaxies as they were billions of years ago. Because light takes time to travel, looking far away is the same as looking back in time. We can now see galaxies that formed just a few 100 million years after the Big Bang, catching a glimpse of the universe's youth. These galaxies look small, clumpy, and chaotic, but inside them, the process of star birth was raging. Massive stars were forming, shining, and exploding, enriching the cosmos with new elements. Think about this for a moment. Every atom in your body was created in one of those stars. The carbon in your cells, the oxygen you breathe, the iron in your blood, all of it was forged in the cores of ancient stars that lived and died billions of years ago. You are literally made of stardust. When you look up at the night sky, you are looking at your own history, at the furnaces that created you in a very real sense. The story of the birth of stars and galaxies is the story of us. The journey of stars didn't stop with the first generation. After the massive population 3 stars died, they left behind enriched gas that formed the next generations of stars, known as population 2. These stars contained more heavy elements and could live longer. Many of them still exist today in ancient globular clusters orbiting galaxies. Eventually, even more metal-rich stars formed a population I stars like our Sun. These stars had enough heavy elements to form planets around them, and eventually, life. So the chain of star formation, from the first giants to the stars we see today, was a continuous process of creation, destruction, and renewal. Each generation built upon the legacy of the last, making the universe richer and more complex. Galaxies, too, evolved over time. Small, irregular clumps grew into spirals with graceful arms, or into giant elliptical galaxies containing trillions of stars. Some galaxies collided and merged, forming new structures. Even our Milky Way has a dramatic history. It was formed by the merging of smaller galaxies, and it continues to grow today. In about 4 billion years, it will collide with our neighboring galaxy, Andromeda. The two will merge into a new, larger galaxy, possibly called Milky Way. These galactic collisions may sound destructive, but in reality, stars inside galaxies are so far apart that they rarely collide. Instead, the gas clouds inside the galaxies interact, triggering the birth of new stars. So galaxy collisions are more like cosmic dances than battles, creating rather than destroying. When you think about it, the universe is a place of constant transformation. Stars are born, they live, and they die, scattering their ashes into space. Galaxies grow, collide, and evolve, shaping the grand design of the cosmos. And out of this endless cycle of birth and death, beauty emerges. Without the death of stars, there would be no planets. Without galaxies, there would be no structure. Without the universe's evolution, there would be no us. We are part of this grand cosmic story, connected to it in every way. So the next time you look at the stars in the night sky, remember that you are not just looking at distant suns. You are looking at history. You are looking at light that has traveled for millions or even billions of years to reach your eyes. You are looking at the birthplaces of the elements that make you who you are. You are, in a very real sense, looking at yourself. And this is just the beginning of the story. The universe has continued to evolve in astonishing ways, giving rise to galaxies like our Milky Way, stars like our Sun, and eventually planets like Earth. But that, my friends, is a story for another day. For now, let us marvel at the fact that the dark, empty universe gave birth to light, structure, and life. From nothing, everything emerged. From darkness, stars were born. And from stars, we were born too.